the new stuff today is just kind of another type of equation, another type of function, a different type of graph that you'll see. And we actually do a chapter or two on this in algebra, so you'll see this next year. And it's kind of similar to following the trend we've been doing where we talked about lines, and we talked about quadratics, and we talked about exponentials and step functions. The new one today, 10.5, is going to be polynomials, so 10.5 polynomials. And so this is another nonlinear function. It's another function that's not going to give you a straight line. If you wanted to talk about what really is a polynomial, instead of having to write it again, I'll just do that. And I'm going to say it's an algebraic expression. So what do we mean by that? Because that's maybe as clear as mud. Algebraic expression means simply it has to have variables. For something to be algebraic, it has to have variables. Maybe say has variables. Typically an x and a y, and more than one term, and more than one term. And kind of the generic, the Falk definition of a term is basically like a clump. More than one term, more than one clump. So examples, that's maybe going to be our best way to kind of look at it, would be if we were to have something like a 2x squared minus 5. The terms are typically separated by a plus or a minus. So one term is going to be the 2x squared, and the other one is going to be this minus 5. The reason I'm including the minus is because kind of the generic definition is going to be this is the same as like plus a negative 5. So it's kind of like my second term is technically a negative 5. But I like seeing that as a minus 5 more than the plus a negative. So that would be one polynomial, and it has two terms. Or if you wanted to throw another one in there, we'd have a 3x to the 5th. I'm just making up numbers now. 3x to the 5th minus 7x to the 3rd, and then a plus x. So it could have x a couple times in there, each time to a different power. This is going to have how many terms? 3. Yep, right on there. So 3 terms. One is the 3x to the 5th. One is the minus 7x to the 3rd, and one is the plus 1x. So for this now, each thing separated by a plus or a minus is the term. Yep. So 3 terms. You feeling okay on those? Now we don't go too in depth on these today, so there's no questions. We'll just jump to the others. If you were to have, I'm maybe going to skip ahead to the second one. If you have we rode them in exploratories. They have 2 wheels. They're called bicycles, and the prefix bi means 2. So this is going to be my second one. Does anybody know the prefix for 1?
Unit.
No, it starts with a M.
Mono.
Nice. Mono is like 1. Like mono y mono or something. So first one's going to be a monomial. So a monomial. So poly up here at the very top, poly means many nomials, whatever a nomial is. So if we have something that just has one term, has one clump, we call it a monomial. So that just has one term. And my examples for that, I'm going to say it's like x, or maybe like a 3x squared, something like that. It just has one clump. There shouldn't be a plus or a minus inside it, unless maybe you're saying like a negative x squared or something like that. Then the second one we had was a binomial. So binomial. A binomial is going to be like this one here on the left, this 2x squared minus 5. That it has to have 2 terms. So 2 terms. So it'll have either a plus or a minus somewhere in the middle. You could say examples maybe would be like a x squared minus 4, or a 3x plus 2, something like that. You okay on binomials?
Does there have to be an x in it?
Yeah. We said at the very beginning, you might have been out of the room, but polynomials has to have the variables. So algebraic expression with the variables. So my next one, if you have a 3-wheel bike, it's called a tricycle. So a trinomial. And this is going to have 3 terms then. And for there, I'm just going to write 1. I'm going to have an x squared plus 5x minus 9. So x squared plus 5x minus 9. And it has 3 of those terms, or you could say like that's going to be one term, that's a second one, that's a third, or so on. We okay on those? After that, we just kind of stop, and they'll call it like a polynomial after that. All right, so the next thing we want to cover is going to be a degree. So we'll say degree. And we're just going to look at it where we have one variable, just x's in our polynomial. Maybe it'll be y equals something with an x. But it's for a polynomial with one variable. So for a polynomial with one variable, the largest exponent is going to be the degree. So the largest exponent the variable is taken to. So the degree equals the largest exponent the variable is taken to. So if I were to do a bunch of examples, if I have a 2x squared minus 5, there the degree just has to be 2. Because I have an x squared, I don't have like an x to the 4th or an x to the 5th. X squared, this 2 is the highest power for x. If I were to have a 3x to the 5th minus 7x to the 3rd plus pi, why not, just for fun. So 3x to the 5th minus 7x to the 3rd plus pi, the degree has to be 5. I'm going to try to mess with your head with my last two examples. If I have an x, the degree is Is this an x? I heard a 0 and I heard a 1. Is this an x to the 0 or is it an x to the 1?
X to the 1.
Yep. If nothing's written in, you can assume it's to the first power. So then the degree has to be a 1. No exponent's written in. That's a tricky one. And it doesn't totally fit our definition up there of a polynomial. But if you were to just have a constant like a 4, what's the degree of something like that going to be? Well, degree 4, you could say that's the same as, well, there's no x's in there, right? Do you agree I could say that's 4 times x to the 0?
Yes.
Because x to the 0, really any number to the 0 power, except for 0 itself, is 1. So that's the same as just kind of like 4 times 1. So the degree is going to be a 0. Okay on that one? Then one last thing to hit is, how do we write these things? It comes in handy if you try to write these big complicated ones in a certain order for later on if you're trying to add them or subtract them or multiply them. You start getting things in common. Then to write these, they're written in descending order. So written in descending order. So if you're descending the ski slope, you're going from the top to the bottom. Basically, we go from the highest to the lowest. But the highest what? It all has to do with the degree. So what's the highest exponent? So the highest exponent to the lowest. And the lowest is going to be just a constant. That's part of the reason I put that in there. Like a 4, the degree there is 0. That's kind of like a 4x to the 0. So we end up having the constants, the numbers by themselves, always tag on the very end, on the far right. So I'm going to give you some big, ugly thing and say, write, I'm going to take a second line just to make sure I have space. Write 5x squared minus 2x to the 3rd plus 5x to the 7th minus 8 plus the x to the 5th. So write 5x squared minus 2x to the 3rd plus 5x to the 7th minus 8 plus x to the 5th in proper form. sometimes, and this, I think we could do this fine without this hint, this trick, this whatever, but I found the most common mistake people make in some of these easier problems like this is they just leave out a term. They forget a clump. And especially later on when you start getting, like, you're adding them together, subtracting. Something that I started doing just to keep myself from getting those kind of like, seriously, I got that one wrong, kind of responses after quizzes, is I'll underline ones as I use them. You could cross them out, I suppose, too. But my biggest degree is going to be the x to the 7th, right? So the first thing has to be this 5x to the 7th. So I'm just going to throw an underline underneath it and then write it down. So I have a 5x to the 7th. What has to come next? Go for it, Nick. Well, just the x to the 5th. So plus x to the 5th. So it's kind of like we have a 1. Because you always look at the sign that's in front of it. So technically this is like a positive 1x to the 5th. So we have to write the plus, and we leave out the 1 because it's simplified. So,
you've got like the pluses behind that.
oh, but we're taking the x to the 5th, so we're doing the plus that's in front of my x to the 5th. So for this thing here, we have the x to the 5th, and then the sign in front of it kind of goes with it. So my next one is this 2x to the 3rd. So plus 2x to the 3rd or minus? Minus 2x to the 3rd. And then I have my x squared. So what do I do there? Plus 5x squared, minus 5x squared? Plus. Because it's a positive 5, we just don't have to write it at the beginning of a problem. So we have to have this plus 5x squared. Then the only thing left is this minus 8 here at the end, so minus 8. My plus look a little nicer. So that would be writing it in proper form, or in standard form, maybe they'd call it. So, okay on that one? And very last thing is this here. We'll say evaluate's kind of the math way of saying find the number answer. 3x squared minus 5x plus 2.
Is this an example?
Sure, yeah. I had it down for example too, but it really didn't fit in my heading. So write evaluate 3x squared minus 5x plus 2 when x equals 4. Some people will go through and do it in all little clumps and then combine them all together, and you can do that, but just be careful that you're not violating order of operations. I think it's easier to just go through and let the calculator do all the work for you. But we're going to put a 4 in here. We're going to put a 4 in here. And so really it just becomes you want to punch in your calculator 3 times 4 squared minus 5 times 4 plus 2. And if you just punch all that in and don't hit equals or enter until the very end, then it'll automatically do it for you. So if you punch all this into your calculator, you should end up getting 30. So you could punch it in, try it, see if you come up with 30. If so, you're good. Otherwise, you could do it manually by hand if you wanted to. This is 3 times 16 minus 20 plus 2. So then we have 30, 48 minus 20 gives you 28 plus 2. But either way, you should end up getting the 30. Fair enough?